Welcome to Bodine Electric's Motor University. This series is brought to you by Bodine Electric. Choosing the right gear motor for your design is a stepwise process. Speed, power, and torque are fundamentals, but there are many other important parameters like size and mass of the unit, the current that powers it, and ultimately the cost. For highly constrained applications, a machine designer may have to work around existing gear motor products, but major gear motor vendors offer a multitude of choices. Mechanically, the most important attribute of the gear motor is the relationship of the output shaft to the major axis of the unit. Output can be inline, parallel, or right angle, with parallel and right angle options including hollow shafts. Intuitively, power delivery in line with the motor axis would seem to be the best option, but there are plenty of good engineering reasons to go with a right angle drive. The primary one is the available space inside the machine for the gear motor. There may simply not be enough space for a parallel shaft orientation, and a right-angle gear motor is then the only option, or vice versa. Another consideration when choosing the gearbox type is efficiency, with parallel shaft gearboxes usually being more efficient than right angle. That is because the most common gearing type in a right-angle gearbox is worm gearing. Worm gearing involves a sliding action between the worm thread and the teeth of the mating gear. There is more friction and more heat produced, resulting in a lower efficiency than the meshing action of spur and helical gearing. Although worm gearing is the most common type of right-angle gearbox, it should be noted that it's not the only type. Hypoid gearing, for example, is a right-angle gearbox with efficiency that rivals that of a parallel shaft gearbox, but it's generally more expensive than worm gearing. Applications that especially benefit from high efficiency include battery-powered mobile machines, where a less efficient gear motor would drain the battery quickly. The need for a hollow output shaft may be another reason for the machine designer to choose right angle over parallel shaft. Although a hollow shaft can be found in both configurations, it's more commonly available in a right angle gearbox by far. A hollow shaft can simplify assembly and reduce the overall machine cost by eliminating couplings where there is already a shaft in the machine. One example is a conveyor where the roller is already supported by a shaft, and that shaft can be extended for the hollow shaft gear motor to slip into. Lastly, an application may benefit from having a self-locking gearbox that can hold a load in position against gravity even after power is turned off. Worm gearing is, by virtue of the geometry of the worm, generally self-locking in ratios above 20:1 under static conditions. Any other gearbox type would require the addition of an electromagnetic brake onto the end of the gear motor to hold the load in place if the power is turned off. One application that usually has a worm gearbox for self-locking is a stair lift, where it's necessary for the seat to remain in place if there's a power failure. Companies with a wide and deep offering, like Bodine Electric, have specialty products which can simplify the design process and improve reliability. There are literally thousands of combinations possible. This series was brought to you by Bodine Electric. For more information, visit bodine-electric.com.